is David Richardson. Welcome to the High Performance HVAC podcast. With me today is Adam Mufich from National Comfort Institute. Adam, it's been blazing hot in East Tennessee. We're down here doing recording, shooting some video. We got off on the side conversation of equipment sizing because there's been so many complaints of equipment not keeping up. You had a great story I thought would make for a good session.
Yeah, so there is one thing I wanted to point out. We had a conversation with our producer here, Nick, this morning. Right, his in laws, the temperature in their house is actually struggling a little bit. So it's 100 degrees outside, right? And every area has a design temperature. So when you have a design temperature, that's like the 99% worst case scenario. And if you're above that temperature, you start running into issues where you might not maintain your desired set point in a house. So I want to ask you, what was your best practice, and what would you say? How would you have that conversation with homeowners back when you were in the field if they were like, "Hey, it's 100 degrees outside and it's 75 in my house. I wanted it at 69."
The conversation, the answer to that is what no homeowner wants to hear because it's doing what it's supposed to do. But that's not what they want to hear. And that's the hard part. When you try to explain to them that the system is doing what it's supposed to do. And I think that's one of the things that prompted oversizing so much. And we probably unintentionally oversized systems more than we intended on because of that very thing. No contractor, when it's hot like that, stuff's already breaking down. The last thing that they want to hear is your equipment won't cool. My equipment's, it's uncomfortable in here, even though it's doing exactly what it's supposed to do.
Right. And I guess the thing is, like, should you design a system for to be comfortable the 1% of the year, 80 hours of the year? Is that your goal, to be comfortable during that time span, or would you rather have something that you're going to be comfortable the main majority of the year and maintain a healthy humidity level inside the house?
And
Right.
I think we both know the answer to that, but it's a tough one because it's one that many struggle with.
Yeah, I had a phone conversation yesterday morning. I had a friend of mine call me up. He installs in the field, and he removed the existing equipment. They were keeping the existing furnace, and they were installing a new evaporator coil and condenser. And the new equipment showed up on the truck,
Yeah.
and it was a 4 ton. They didn't run a load calc on the house,
Yeah.
but he turned around and he looked at the house they were working on, and it was a townhouse. It was the center unit of a townhouse. So what's the first thing that comes to your mind when you think of a townhouse?
Yeah. There's like no exposed sides except like maybe one or two, depending on,
Right.
the orientation.
And I know a lot of people instantly start thinking about, like, all right, well, this is a 2,000 square foot townhouse. But then you think of, your sidewalls. We don't have any exposure, like you just said, but
Right.
then it's a two-story townhouse too. So one of the main loads of any house as far as heat gain is the ceiling.
Yeah.
The first floor, there's no heat gain on the first floor ceiling,
Yep.
right? So you have very little exposure across everything. So he had a gut feeling, hey, we need to install something smaller. So what happens, you've been teaching high performance HVAC for a long time, right? You have a 4 ton system. What is the first thing you think of when you have, if you have a 4 ton system, do you have adequate ductwork? If you don't have adequate ductwork, what happens?
Oh yeah, you're going to have high external static pressure. Depending on the fan motor type, you're going to have premature failure, continuous problems. Inverter based equipment, fan failure errors are popping up left and right, and because a lot of this is just like for like sizing versus, as you're saying, putting the right size piece of equipment in. So when you look at those situations like that, there's so many times that the bigger box is what the typical go-to for most people instead of what does it actually need. And going back to your original point, are you going to design for that 1% of the time, or you want to make sure that it's sized right for that 95% of the time when technically it really is going to be oversized then if you're only sizing for design condition.
Right. And one thing that I think a lot of people skip, that I skipped for a really long time, was actually measuring airflow.
Oh yeah.
Now, in this situation, it was an older furnace. It was a PSC or constant speed blower motor in that
Right.
furnace, right? So, unlike ECM motors, where is the sweet spot for the static pressure, the total external static pressure?
Right. And it's going to be right on that rated.
Right on the rated, point
Yep.
0.5. You're going to get your, if you have a 4-ton drive, you're going to have 4 tons of airflow at half inch,
Right.
right? So you start running higher static pressures, all of a sudden you have reduced airflow.
Right.
So you have reduced airflow in an existing system. I know there's like a fear factor that a lot of contractors have. I don't want to go too small because that's when I get sued, right?
Right.
But if you install a 4-ton, if you do a like for like and you don't have the right amount of airflow, your 4-ton is not a 4-ton.
Right.
You're not delivering those BTUs.
Right.
And there's ways that actually that we teach, right? Um, you could do pretty easy testing to figure out what the actual capacity, the delivered capacity of the equipment is.
Oh yeah, and it doesn't take much. I mean, you can either estimate airflow with a fan table if it's fairly new; it'll get you very close. Measure it with a digital true flow grid from like the TEC, and if you've got two psychrometers at the equipment, you can do some simple math and get a really quick estimate on what the capacity of that system is. And you can see how much of it's going to total cooling, how much of it's going to sensible cooling, which is going to drop in the space temperature, and also how much of it's going to removing moisture, how much of that's just condensate going down the drain, and get a really good feel for what the capacity that system is doing under its current operating conditions. It's and the one X factor we haven't talked about. You mentioned people getting sued for undersizing. Uh, One of our friends, Zach Ortwine, had sent us a message from, I think it was from Virginia Beach, where there were contractors out there getting sued for oversizing because now they were having all kinds of problems. So if you're too small, too big, you're going to have a problem. And the one thing that we don't talk about, as you mentioned earlier, Adam, are the ducts that it's connected to. How are they affecting that system's capacity? And this is one of the things I think that we overlook is we really nail down the equipment size and we focus on making sure that it's the right size. We'll go through the proper load calculation, we'll do the equipment selection procedures, but how many of those BTUs are making it from the equipment into the conditioned space, into the occupied space? That's what that customer feels. And if they're losing those BTUs through the duct system, they're not getting what they're paying for, regardless of it's a right size system or not.
Right. And I took that I took a lot of that for granted for a long time and
Yeah.
actually measuring delivered BTUs. And there's like a misnomer or misconception that in the Midwest, right? We have it's a predominantly basement construction type style house. You have basements, first floor, second floor systems, and most of our duct work is in the conditioned space in the basement.
Right.
So we don't insulate our ducts. And I know, posting pictures online and seeing people regionally in different areas, they think we're nuts. So like, how do you not insulate your ducts?
Mhm.
Like, doesn't matter. It's in the conditioned space, right? But when you start comparing the equipment temperatures versus the delivered temperatures, you start seeing the loss and what you're actually losing. So um, I used to think, all right, we need to figure out how much airflow we need to each room. How
Right.
much do we need to this space right here? It's possible to have the correct amount of airflow, but still be uncomfortable because you're losing those BTUs, right?
Right. That's a great point. Just because you've got the airflow doesn't mean you're going to have the comfort. I mean, think about how most service calls are happening right now. Outdoor units not running, but they've got the airflow, but they don't have the BTUs. So that's one piece of the equation for whether you've got the sensible BTUs or whether you've got the latent BTUs being removed on the moisture side. And you mentioned equipment temperatures versus system temperatures, and this is something I think our industry overlooks. I used to overlook it because we did the same thing. We're in Central Kentucky, mixed climate, so we've got stuff in basements, stuff in crawl spaces, attics, you name it. We see things all over the place. So you may have one system where your ducts are in a great area, and you go upstairs to the second floor, and they're in an attic where they've got a load around those ducts that they were never designed to handle in the first place. We're the only industry that's crazy enough to stick ducts in a space that we're trying to pass 55-degree air through it and then put it in a space that'll get up to 140 degrees. That's a massive delta T. And then we wonder why it doesn't heat and cool the space right. And just comparing temperatures at the equipment to the farthest return and supply registers, it's insane what type of diagnostics that opens up when you're looking at uncomfortable rooms. So many guys will go in and they'll say, "Oh, we need bigger equipment." When in reality, what they need is to go out and fix the ducts and make sure that you're not losing capacity or tonnage through that existing duct system.
Yeah, and to kind of go back to airflow too, like I don't think a lot of people, a lot of technicians, especially guys younger in the trade, they don't see the importance of airflow,
Yep.
right? One of the biggest things is, you ask somebody, well, you need to know what the airflow is. Well, my airflow is good.
Yeah.
And I think TEC has a sticker, the Energy Conservatory. Airflow is not good; it's measured,
Yep.
right? Um, Airflow is the fluid. Air is the fluid that carries all BTUs throughout the home and delivers it to the space. So when you have an oversized system, if you have inadequate airflow, if you reduce the airflow to a system, you're reducing the total capacity and you're reducing the sensible capacity. And like you said, the sensible capacity, that's the number on your thermostat, right?
Right.
That either increases or decreases. And when you reduce the airflow, you're increasing the latent. And they kind of flip flop. So you're not going to have good latent and good sensible. It's one or the other.
Great point. And going, going, I can't this relationship between the equipment and the system. So many times, I know I harp on this a lot, but our industry calls the equipment the system, and it's not the same. And it totally degrades the craftsmanship and the workmanship that the installers, the designers, the techs in our industry bring to the table because it tries to put everybody on a level playing field, and we know that's not the same. Just because you put a box in, that doesn't mean it's the system. It means it's a component of the system. How that system is designed, how it's assembled, all the details in that. You had talked about, we were having a conversation a couple of weeks ago about even the evacuation side of it, doing a decay test. I mean, things like that. Those are the details that separate the equipment from the system. And as we start looking at, how these two tie together, many times that duct system component, if you've got ducts in an unconditioned space like an attic, that could be up to 40% of a building's load. So you account for that. And all of a sudden, if you're trying to put a bigger box in, more capacity, if you just fix the ducts and you downsize the equipment to what's a proper size, your renovations on those ducts don't have to be all of a sudden they're not as massive as what they would be if you tried to put the bigger equipment in there.
That's a great point. I found that a lot of times you could just make modifications near the equipment at that point, right? Because
Right.
your branches and your trunks are a lot closer to be appropriately sized for the system. One other thing that I wanted to mention is, you know, I've had conversations with different contractors in that when they talk about, you have an inverter based system and you can't really oversize an inverter because it just ramps down. The thing is, any inverter has like a bandwidth that it stays within. There's a range that it
Right.
operates with, and there's a minimum capacity and there's a maximum capacity. And then I have the conversation with them, what do you do if it's oversized? It's not going to dehumidify. And then they say brand X has a dehumidification mode, right?
Uh-huh.
So what happens in dehumidification mode
Yeah,
in most pieces of equipment? How
we're
does it work?
slowing the blower down or we're increasing the runtime.
You're slowing the blower down, right? You're increasing the latent capacity.
Yep.
And by doing so, what happens to the efficiency of the equipment?
Oh, it goes south.
It falls off a cliff. So the people that are oversizing, if you get into the habit of oversizing in an inverter and you're basing the safe operating conditions on running a dehumidification mode all the time, that 20 SEER piece of equipment you installed might be running at a 16 SEER on average,
Yeah.
right?
And we can prove that through measurement. That's what's so cool about measuring is you don't have to guess. You can measure and prove what you're getting.
Exactly.
You made a statement at Summit last year that stuck with me. An oversized inverter system is the most expensive single stage equipment. And I'm paraphrasing, correct me if I'm wrong, but that an oversized inverter system is the most expensive single stage equipment you'll ever buy.
Absolutely. I believe that wholeheartedly. I think that there's a lot of systems out there that just basically chug along on the lowest capacity, and that's all it does, And I've talked to homeowners where they're like, "You know what? I want the added capacity for just in case I have a party at my house or this or that." It's like you don't design a system for those like one-off conditions that
Right.
happen like one day a year or whatever. I want a safe and comfortable and efficient environment the majority of the time that it's operating.
Right. So we may have listeners that are wondering, what are the steps to make sure that I've got the right size piece of equipment in a home? What are those steps? What would you do to go through and make sure that you've got the right sized equipment instead of just going in? And I know mainly we're talking to a retrofit audience, but instead of going in and matching up the model numbers, going in and actually seeing what does this building need based on where I'm at.
Yeah, so I think the biggest thing is when you're using like some of the bigger, more cumbersome software out there,
Mhm.
you really need to understand what's important in a load calculation. Conduit and Amply makes it pretty easy to do, but I do recommend if you're going to start doing that and using a Manual J software, maybe take a class on load calcs and the ACA design manual so you can understand what really impacts and what swings the load in either direction.
You mentioned manuals, plural. And that I know that was a big mistake that we made early on was that we assumed that the load calculation was the equipment size. And that was where we stopped. And I know that sometimes we may have been close, and other times we were probably like way off. And then we learned that there were some other letters in the alphabet that we needed to follow when it came to equipment sizing.
Yeah, Manual J actually has nothing to do with equipment sizing. All that is heat loss and heat gain of the structure,
Yeah,
right? Like Manual S, that's like that is the manual for equipment sizing. You're
right,
selecting the appropriate equipment, and Manual S gives you guidance on, maybe in certain circumstances you could slightly undersize the system and
right.
still be acceptable. And then other circumstances, they give you a range based on the type of equipment you're installing and how far you could oversize the system.
Yeah,
And the biggest thing is, especially with on the cooling side, you'll if you oversize it too much, then you start reducing runtime, and you also your dehumidification falls off a cliff.
right. And I know one of the things we've referred to is the different capacities at different conditions of a system. I mean, you've got indoor entering dry bulb, indoor entering wet bulb, your airflow, as you mentioned, across the coil, and then outdoor temperature. And as those four variables change, so does the capacity of the system. If we're not accounting for that, we've got problems. It's easy to assume that there's 12,000 BTUs per ton. Unless you're melting a block of ice, that doesn't apply. And as those four conditions change, it makes a big difference.
Yeah, I and if you're skeptical on, how important airflow is, I challenge anybody to look at the performance data for any piece of cooling equipment and
Right.
look at see what airflows they're rated at, because usually they give you three specific airflows that give you what the capacity is, the total cooling and the sensible. It'll give you
Right.
a sensible heat factor. So it's a sensible to a sensible to total ratio.
Yeah. And one of the things I found is that many manufacturers, there's no consistency in how it's rated. A lot of times you may have to back out of it, but there's also times that when you look at it, some manufacturers will have it listed a little bit differently. You got to take a look at that from a little bit different standpoint. Some will say S/T, which is the sensible to total ratio. Others will say sensible heat ratio. Others will say like TBTUs for total BTUs. So every manufacturer is a little bit different. That can be, I know, kind of confusing.
Yeah, it would be nice for everyone to kind of standardize everything. And I know, I don't know if it was ACA, but I know there's been like a shift to not call the when we're looking at the equipment, we don't call it really sensible heat ratio anymore. Now there's a push to call it sensible heat factor. They're separating it from the house, so they want to call the capacity, the requirements for a house, the sensible heat ratio, and the equipment is the sensible heat factor. But it would be really nice for the manufacturers to kind of standardize all this so it would
Right.
make it less confusing for everybody, right?
You mentioned separating the HVAC from the building. I thought that was interesting that you said that manual J's are all about the building. It has nothing to do with HVAC, but it has everything to do with HVAC because it's 100% building science. And for those that are looking at a right size system, if you don't have an understanding of building science, that really needs to be something that you put on your to-do list is learning how a building works because it is an extension of the duct system. If you look at any HVAC system, The building is what connects the air from the supply registers back to the return grills. It's what completes the closed loop of an HVAC system.
Right, and there are times too. I've had in the past where you have everyone's had trouble jobs. You have
Yeah.
issues where you're like, I don't know what's going on with this, right? But years ago, if I had a system that somebody was complaining about something's not heating right or not cooling right, the first thing, the easiest thing to do is be like, hey, I can go install a bigger system, or I could refund their money back.
Right.
But then you start learning, like you said, about the house. The house is a system, and you start learning about HVAC performance and measuring BTUs and air balancing and all that. And suddenly you start connecting the dots. The one thing that you notice if you run into enough troubled houses is there's certain circumstances where you can't out HVAC a house. You need to fix the house itself.
You were talking about that this morning on that one problem job where it just properly sized equipment, tested out, measured BTUs, everything was great, couldn't keep up. You went out and did a blower door test, and the house was more connected to the outdoors than it was any place else. So they were basically trying to heat and cool the outdoors.
And I blame that on Joanna Gaines. If you guys know who that is from that reality TV show, it's that darn shiplap. Everyone thinks shiplap is it's the trendy thing to do, but man, it's like having Swiss cheese for walls.
Yeah, it makes them ducks. It's that's crazy. You mentioned something that I think a lot of contractors have gotten bitten by, and that's if this piece of equipment or quote unquote system doesn't work, we'll pull it out for free. And there've been a lot of guys that have had to go back on that. And I think there's 3 steps. If you find yourself in this situation, there's 3 steps. First, start at the equipment. Adam mentioned a simple way to measure BTUs earlier. Measure the BTUs at the equipment. If you've got airflow measurements and you have a delta T, delta H, which is an enthalpy change across the unit, you can calculate approximate capacity right there. If it's doing what it's supposed to, you just checked off step number 1. Step number 2 is go to the system. And now you're going to, instead of measuring BTUs at the equipment, you're going to measure BTUs at the system, what's coming into the conditioned space. And if that checks the box, if you're within 10% of what you've got at the equipment, you can check the box on the HVAC system. And that means your portion of it is doing what it's supposed to do. And that's when you go to step number 3, which is looking at the building, the BTU container, because that's what has to hold the BTUs. If it's leaking, then you could have the ideal HVAC system, and it's not going to maintain comfortable conditions.
Absolutely. Yeah. There's just some homes that, there you really just have to fix the house. And I know, the easiest thing for most homeowners, they connect the dots, my house is not heating or cooling well. It's something with the HVAC. But
Great point.
even new houses, they have issues with it. And just because it's new doesn't mean it was built well.
Yeah.
Right. There's certain craftsmen out there that they're the best in their trade. And there's other people that they're not at the top of their game. Maybe they're
Right.
just getting started, so they're still learning. And unfortunately, everyone in the trade touches all these houses, so you don't know who's actually working on your house, right?
Yeah. So what you're saying is no homeowner who's uncomfortable will ever point the finger at the insulation guy and say, because you didn't put enough R value in, I'm uncomfortable. Or because you didn't weatherize the house, because it leaks like crazy, I'm uncomfortable. It's always going to fall on the HVAC industry.
But when we look at the house as a whole and comfort and efficiency and safety, the whole aspect of it, think of it like a big team, and it's almost like an orchestra that's going on, and everyone has to do their part, and everyone has to do their part well,
Yeah.
right? So we have equipment sizing, we have air sealing, insulation, and then you have the installers that have to do their job. They have to seal the ducts. They have to install the correct size ducts. Um, Everyone's got to do their job. So it's not just equipment sizing. Just because you have an X size piece of equipment and you have comfort issues, there's a much bigger picture that you need to pay attention to see what could potentially be the problem.
So there's always that one guy in the orchestra banging the cymbals. You just got to measure to find it.
Yeah, that was me when I was a kid.
Adam, this has been a great discussion. I hope you guys benefited from it. Thanks for tuning in. We'll catch you next time.